Greetings of the day, dear students. In this video, we are going to discuss about the different applications of the diode. By the time we complete this video, we are going to discuss about the some common applications of the diode. Those are rectifiers, clipping circuit, clamping circuit, and how a reverse current protection circuit will look like, and how it is used in the logic gates, right? And also about the voltage multipliers, and we will see their circuit diagrams and its operation as a diode rectifier, and also we will discuss diodes in the clipping circuit. What do you mean by a series clipper, and what do we mean by shunt clipper, like this clipping circuits, its waveforms, and also we will discuss the clamping circuit. What do we mean by positive clamping and negative clamping circuit, and also we will discuss the use of diodes in logic gates, and how it is used, how a diode is used in voltage multiplier circuit, its operation, and also we will discuss the diode in reverse polarity protection, and finally we will discuss the diode in voltage spike suppression, its circuit diagram. All those things will be discussed in this video, right? Dear students, please observe, coming to the different application areas of the diodes. It will be including the communication system, right, where we are having limiters and clippers and gates, etc. And in computer systems as logic gates and clampers, and in power supply system some applications are in rectifiers and inverters, and in television systems as phase detectors, and in radar circuits as in gain control circuits, etc. Like this, in different fields we are going to use these diodes, right? Out of all these, some common applications are rectifiers, clipper circuit, clamping circuits, and in reverse current protection circuits, in logic gates and voltage multipliers. These are the some common applications we are going to discuss, right? Now out of that, the first one, diode as a rectifier, right? Here the purpose of the diode in a rectifier is it converts the AC power to the DC power. Now in these rectifier circuits we are having half wave rectifier, and we are having full wave center tap rectifier, and we are having full bridge rectifiers. All these three in detail we have already discussed in the previous videos, right? But coming to its basic operation, where it converts the input AC waveform into a pulsating or DC waveform. In this simple circuit, during the positive half cycle of the input voltage, during positive half cycle of the input voltage, this diode D1 will be forward biased and will act like a short circuited path, and whatever the current applied voltage is there, that will appear across the load during the positive half cycle within the time period 0 to 5. Now during negative half cycle, right, the diode will be under reverse bias mode, and there won't be any conduction, and it almost acts like a open circuit within the pi to 2 pi time period, right? Now this pi to 2 pi, it acts like an open circuit. This diode acts like open circuit, and there won't be any conduction, and no voltage will appear across the output. Here across the output we have connected a load resistor RL. A load resistor RL is connected across the load. So from pi to 2 pi, again there is no conduction through the diode, right? Like this, it is going to convert the given input AC waveform into the pulsating DC, right? So this is how we will use the diode as a rectifier circuit. Now if you use filters there, we can further get remove the ripple contents, and we can get the uh, pure DC by using the filter circuits. Coming to the diodes in clipping circuit, what happens is some part of the voltage can be put off, right, beyond the preset value without disturbing the remaining part of the input waveform. For example, if you observe, if this is the input waveform during the positive peak, and here we are having the negative peak, but this diode anode is connected to the load resistor RL, cathode is connected to the source. So during positive half cycle, it will be reverse bias and there won't be any conduction. This entire positive part is removed. But during negative half cycle, this diode will be forward biased and now there will be conduction in the diode. Like this, we can allow only the negative peaks are allowed, negative half cycles are allowed, and all the positive half cycles are clipped. They are not allowed to pass through to the load. Similarly, here you can observe this diode is connected in series with the load. It is connected in series with the load. So this is a positive series clipper. Now similarly you can connect the same clipper in parallel to the load. It is connected in parallel to the load. Here also you can observe during positive half cycle this will be forward bias and it will act like a short circuit. Current after or voltage after coming up to this point, entire thing pass through this diode. And during reverse bias, during negative half cycle of the applied voltage, this diode will act like a open circuit switch, right? Now whatever the waveform is there, that will appear across the load, so it will not flow through the diode, and during negative half cycle that will waveform will be passed through the load resistor RL. Like this, here also again we have clipped out the positive waveform, and but the difference in the above circuit and below circuit is here the diode is connected in parallel to the load resistor RL. Like this we can use to put off some preset value of voltage, right, like this. So using clipper positive half cycle of input voltage is removed, that positive half cycle is removed, right. Now coming to the one more application, that is the clamping circuit. What happens is here no part of the waveform will be removed, but it will be simply shifted either to the positive side above the zero axis, or it will be shifted towards the negative region below the zero axis, below the origin or above the origin. That such kind of shifting can be made with the help of this diode, right. It can use it to shift or alter either positive or negative peak of the input signal to a desired level. So this is called the level shifter or DC restorer. Coming to the, we are having two types. One is the positive clamping circuit and another one is the negative clamping circuit. In this waveform, you are having positive half cycle and you are having the negative half cycle at the input side, okay. And this in positive clamping circuit, negative peaks are raised upwards. This entire waveform is just shifted upwards like this, right. And in negative clamping circuit the positive peak falls at the zero level. Like this the diodes will be useful to in the clamping circuit. Now sometimes depending upon the on state and off state of the diode, on is considered as high and off state is considered as low, and if it is high the 1 and if it is low 0. Like that it can be used. The low and high impedance states of the logic switch are analogous to the, they are analogous to the forward and reverse biased condition of the diode. If it is forward biased high, 1 will be given as an output. If it is reverse biased off, low will be given as an output with the help of the logic gates. And this diode can perform, using these diodes we can perform the operations of AND, OR, and some other operations can be performed. Similarly, in a voltage multiplier circuit, what happens is you can observe the input voltage is only just V input voltage. V input equals to some Vm times sine omega t, but at the output point we can observe we are going to have 2 times the Vm. How it is possible? For example, during the positive half cycle, this capacitor will be charged, this diode will be in the forward bias mode, this diode will be in conduction, and the capacitor will get charged, During the positive half cycle, this diode D1 is forward bias and diode D2 is reverse bias. During negative half cycle, what happens is during negative half cycle, you can observe during negative half cycle, now the same diode will be reverse bias, and but this diode will be in the forward bias. Now whatever already the capacitor has been charged to plus Vm, and now again we are applying the voltage Vm. So two times the Vm amount of voltage will be charged, up to that level voltage the capacitor will be get charged across the capacitor C2. This is the path during the negative half cycle. Now the voltage available across the output will be two times the Vm. One is 1 Vm is already due to the capacitor charge to the voltage of Vm, and the another Vm is due to the applied voltage. Like this, the voltage can be multiplied. The voltage can be multiplied, and now this voltage multiplier circuit will be of different types. Like voltage can be a doubler circuit, tripler, quadrupler, etc. By using the diodes combination with capacitors, this is all possible. By using the diodes combination with capacitors, we can achieve this target, right? We can get either the odd or even multiples of the peak input voltage at the output. We can get those things across the output, right? So this is how the application of the diode in a voltage multiplier circuit. Next one is the, sometimes there will be the loads where only forward conduction will be allowed. During reverse bias mode there should not be any conduction to the source. Okay, so there is a requirement where such that if you place a diode in series with the load, right, it is going to block. This is called blocking diode. During forward bias condition state, it will act like a switch and it will be short circuited, and if any reverse bias condition occurs, it will be open, and you can protect the source, right? So this reversibility or the current protection is necessary to avoid the damage that occurs due to the connecting the battery in a wrong way or reversing the polarities of the DC supply. In order to protect the solar panels also, okay, in order to protect the solar panels and inverters, these diodes will be used. These blocking diodes will be used. So the protecting diode is connected in series with the positive side of the input to avoid the reverse connection problem. If any reverse connection unfortunately happens while connecting the batteries to the load, this can be safely protected by using a blocking diode, right? So the major thing is during forward bias it will be conducting, and during reverse bias it acts like a open switch, and it is going to isolate the load and the source. Load and the source will get isolated if you connected a diode in between these two. During forward bias it acts like a closed switch, and during reverse bias it acts like a open switch, right? Like that we can diode is used in the reverse polarity protection. And one more application is the last application is the diodes used in the voltage spike suppression. Here in this context, what happens is when a source is connected to the load, and the loads which are highly inductive in nature, if there is any sudden changes, removal of the supply source, it is going to produce the higher voltages due to the stored magnetic field energy. Especially with the energy storing elements, we used to come across this problem, especially inductor. In case of inductor or inductive loads, if any sudden removal of this supply source will happen, then it is going to produce higher voltages. So one thing we can do is we can just add a diode in parallel to the inductive loads like this, where it is going to provide some path for the high voltages generated when there is a sudden opening of the source switch, right? So sometimes these diodes can also be called as these diodes are called by different names in the different circuits. They will be called as snubber diode, flyback diode, or suppression diode, freewheeling diode, and so on. Depending upon the circuit you are using, it is going to have different names: snubber diode, flyback diode, suppression diode, freewheeling diode, and so on, right? Here how it works, it is going to limit the large voltage spikes, right? And when the switch is suddenly open, a voltage spike is created in the inductor. Therefore the freewheeling diode makes a safe path for the flow of current to discharge the voltage offered by the spike. because of this diode, whatever if any high voltage are there, those will get circulated or discharged through this path diode. Once the switch is suddenly open, it provides a path for the circulating currents to flow through, right? So this is what all about the applications of the diode. So we have seen diode in voltage spike suppression, and we have seen diode as a reverse polarity protection, diode as a voltage multiplier, and diode in logic gates, and diode in clamping circuits, and diode in clipping circuits, and diodes as a rectifier. So these are all the different applications, right? Thank you.